Hello, welcome back. I'm Dr. Michael Long. Today, what I want to talk about is looking at capital allocation, how we can divide our money up between a risky asset and a risk-free asset, and how we can control our overall risk, what we call a complete portfolio, and the rate of return we're going to earn. So just real quickly, so what we're doing in this chapter right here, first is looking at the capital allocation. And while we're talking about capital allocation here, from this perspective, we're going to assume we have a risky portfolio, and it's made up of purely all risky assets, stocks, bonds, and different types of stocks and things. Risk-free asset, we're just going to define it as the T-bill. Okay, so what we want to do then is we want to look at what is the trade-off, at the risk-return trade-off, as we allocate our money between these two things here. We could take, so what I'm going to do is this. Let's suppose you have $500,000 that you have available for investment, and you're trying to decide, how am I going to invest that money? Well, this $500,000 is going to be called our complete portfolio. And we can allocate this money in any way we want to between a risky set of assets, we're going to call it the risky portfolio, and between the risk-free asset, which we're going to call T-bills. Now, from your textbook, you're just going to memorize these type of symbols and know what they are. Symbol-wise, the amount of money of our complete portfolio, the $500,000 in this example, that we're going to allocate towards the risky portfolio is symbolized by the letter Y. So Y is the percent of my complete portfolio, or percent of my $500,000 that I'm going to put at risk. Of course, the remaining amount would be 1 minus Y. Whatever I don't put at risk, I'm going to take the remaining amount, which would be 1 minus Y. That will go into my risk-free asset T-bills. Okay? So, let's go back over here. I'll put up on the board an example. Let's say we have a risky portfolio. Now, we're going to look the next chapter more how we pick this portfolio, but we're going to call this an optimal portfolio. In other words, this portfolio is going to give me the best possible risk-return trade-off that I would want as a risk-averse investor. So let's just say what this is made up of. We have money into a large stock fund, we have money in a growth stock fund, and we have money in a corporate bond fund. Here's the associated rates of returns. The large stock fund is going to get 11%. Here you're going to get 16% off of this and only 8% off the bond fund. So this is a blend. How are we going to blend this? Well, here's what the portfolio looks like. Whatever money we put here, okay, we can put, $0 here, $1 here, $1,000 here, $500,000 here. We can put any amount of this money, any percentage, Y, into this portfolio. Whatever we put here, the way we're going to invest that money is going to be 40% of the money that goes in here is going to be put into the stock fund, large stock fund. 35% is going to be put into the growth stock fund, and 25% is going to be put into the bond fund. Of course, all this adds up to what? 100%. So this is how our money is, whatever we put at risk, and this is how we're going to allocate our money here, okay? So be careful in getting these W's here confused with the Y's here. The Y is the percent of my complete portfolio. How much money am I going to put at risk? That's what this is doing. How much money do I put at risk? Once I've made that decision, the money I put here, this is how I'm going to divide the money up. Okay? What is the rate of return off of this portfolio? Here's the formula for the rate of return of a portfolio. Is WI times RI, and then you sum all these up. So it'll be, in this case here, like W1 times R1, W2 times R2, W3 times R3. Add them all together. This is called a weighted average rate of return here. And of course, the W's represent what? It's the percentage of your money that's invested in each individual particular security. Okay? The R's, of course, are the corresponding rates of return. Well, I did the math for you right here. So I've got here 0.4 times 11 plus 0.35 times 16, 0.25 times 8. If you add all those together, you come up with an expected rate of return of 12% on this portfolio. Now, this is a number I'm just giving you for purposes of this lecture. We're going to assume that the standard deviation, in other words, the riskiness associated with this fund is 18%. So in the next chapters, we're going to look at exactly how is this number calculated, but I'm just giving it to you for right now. The T-bills, we're going to assume are being invested. You can earn 3% off T-bills. Okay? So our key things here, so in our risky allocation here, for $500,000, we can put some money earning 12%, some money earning 3%. That's going to be our capital allocation, and we're going to look here as we go through how that's going to affect the risk-return trade-off associated with that. I didn't write it on the board here, but what is the standard deviation of the risk-free asset? Well, it's risk-free. The standard deviation is assumed to be 0. Okay, 0. So let's work through just a quick example here. Let me just write right here the I'll give myself a little bit more room. So we had here RP was 12%, sigma P 18%, and our F was 3%. So let's work through this right here. Let's assume, as an example, let's assume Y equals 0.60. Okay, if that's equal to that, then of course 1 minus Y must be 0.40. So what does that mean again? Let's go back here. I'll keep this definition up here. Y is the percentage of our complete portfolio. Complete portfolio is the total amount of money we have to invest. That's the percentage of that amount we're going to put at risk. Okay? Look right here. So I'm going to put 60% of this money at risk. Obviously, I'm going to put at risk then $300,000. Okay? $300,000 is going to be put at risk in the risky portfolio. Well, what do we do with that money? How is that money basically? Do we want to try to divide that up? Well, I'm dividing it up by this right here. So let me just keep it simple here. Let's just call this the large stock. Okay, this is the growth stock, and this is the bonds. Okay, so here's the individual things. How do we have our money divided up into this? Well, look right back up here. 40%, 35%, 25%. So here's the way we're going to break this $300,000 up. $300,000. Take 40% of that, 0.4. That means I'm going to put $120,000 into large stock fund. Okay. The growth fund, I'm going to put 35% into $300,000. That is $105,000. Okay. The remaining amount, 25%, it goes into $300,000. That is going to be $75,000. And what amount went into over here? The remaining amount, 40%, 60% went into risky asset. That means 40% goes into T-bills. So in other words, T-bills is going to be 40% of this right here would be, of course, be equal to the 200,000 T-bills. Okay. So if you want to look what your portfolio looked like, really, here's your risky portfolio. And there's your risky portfolio. Your T-bills is going to be 200,000. So then your complete portfolio is the $500,000. So I kind of broke it down for you right here, the way it is. Now, really, the key thing, we go to calculate what is the rate of return on our complete portfolio. We're going to use something similar I just had up here a second ago. You're going to keep seeing this over and over again, where we tend to use weighted averages in finance and calculate these rates of returns. So how would we calculate that? Well, we could certainly look at each end of it and what percentage of my money I've got invested here and work it through using these numbers, but I don't really need to do that because I know that the money invested in this portfolio spread across here this way, the money invested here is going to earn on average about 12%, okay? The money invested into T-bills is going to earn 3%, okay? So just like we did a second ago, when we broke this up, if I'm using Y as 0.6, what does my return look like for this complete portfolio? Well, the return on my complete portfolio, I'm going to use RC here for our return on the complete portfolio, is going to be a weighted average. It's just like the portfolio we did up here. We took the weighted average based on this W times R's and summed them up. Well, how's my money broken up here? Well, it's only broken up in two different ways. It's put into the risky portfolio, risk-free portfolio. So the return on this is simply going to be Y times RP, okay? The percentage of my money invested in the risky portfolio times the return on the portfolio plus 1 minus Y times RF. 1 minus Y is the remaining amount of my complete of my 500,000 that's going to be put into T-bills. So if I work this problem out right here, this comes out to be what? 60% in this example was put at risk. That money is going to earn 12% on average. The remaining amount, 40%, was put in T-bills. That's going to earn 3%. So let's do the math. 0.6 times 12, 7.2, 0.4 times 3, 1.2. You add the two together, I come up with a rate of return of 8.4% for this RC. There's my expected rate of return off of my, what is this off of? This is off of my, this is my $500,000. Okay, that's what that's the rate of return I expect to earn on this 500,000. It's broken up in these two ways. Okay, 200,000 is going to earn 3%. $300,000 is going to earn 12%, just like I broke it up just a minute ago based on these numbers right here. How about the risk? How about the standard deviation of our risky portfolio? Not the risky portfolio, but the complete portfolio. We know the standard deviation for the risky portfolio is right here. It's 18%. And what's the risk of the risk-free portfolio? It's going to be 0. So you basically what it's going to work out to be, your formula, these are going to be some formulas you want to kind of have and need for quizzes and things. This is this one. The formula for the riskiness associated with the standard deviation for the complete portfolio is simply going to be Y times sigma P. Okay? It's, again, in this example here, it's going to be sort of a weighted average because the standard deviation in this case here is 0. There's no correlation between these, between this, and they're going to fall out. So what it comes out to be, if you put 60% of your money at risk, then you're going to take on 60% of the risk of this portfolio right here. If I'd only put 30% of my money into the risky portfolio, of course this would only have 30% of the risk. So what does this come out to be? This here will give me 0.6 times 18. 0.6 times 18 right here. So the standard deviation is 10.8% is sigma C. Sigma C. Okay? So what we want to do then is we want to come up and find, is there a relationship here? Fine, we found it out for 0.6 and 0.4. How about 0.2 and 0.8? You know, how is that going to affect things? What I want to do is create an equation called the capital allocation line equation here. And I want to do that just real quickly here, and we'll work through some other examples a little later, but let me go ahead and put that up for us. Okay, so let me put this back up at the top here. I had the RP here was equal to 12%. Sigma P equal to 18%. I have RF equal to 3%. And I'll put these numbers up here just for Y equal to 0.6. What we had then, we found that RC was equal to what? 8.4. Put these up here for reference for us. And sigma C here was 10.8%. So what we want to do here is work through an example of how we can, regardless of what the combination is, we can know what the risk is and know what the rate of return is. Okay? So to do that, what I want to do is just draw a graph here. Draw a graph. And what I want to do is come up and give myself, let me give myself a little bit more room. Let's do it over here. Okay? On this graph, the way I'm going to allocate things, I'm going to say, look, on this part here, the vertical part, we're going to put the required return, and down here, we're going to put the risk associated with the security. Specifically, this is going to be sigma C, since we're looking at the overall riskiness of our complete portfolio, the $500,000 we have invested, and we want to look at how that trade-off is between the risky portfolio and the risk-free portfolio. Well, what we're going to find out here is, if you look at this, this is going to be what we call a linear relationship. If I put 100% of my money, all of it, $500,000, if I put it all into T-bills, what's my risk? My risk is zero, right? It's 100% a risk-free asset. What's my rate of return? Well, clearly, if all my money's in the risk-free asset, my rate of return is going to be 3%. And I would be right here on this graph. Suppose I go to the other extreme. I take all $500,000 and dump it all into the risky portfolio. In that case there, I'm going to be way up here somewhere. Call that P for the risky portfolio. I'm way out here. What kind of return am I earning on that? Oh, well, I'm going to be earning a return, as we worked out, was 12%. That's my RP. What risk do I have? Well, it was given to you in this example. The risk I have is 18%. Okay? Now, this case here, this is my what? It's my complete portfolio. It just so happens at this point, my complete portfolio is 100% in my risky portfolio. So the complete portfolio standard deviation is going to be 18%, right? Remember, go back to that example where we had Y times sigma P. What's Y in this case? Y is 1. 100% of my money is put into the risky portfolio. Sigma C is going to be equal to 18% as well. Well, how about everything in between those two things? You know, so what we're going to find here is actually, this is going to be a linear relationship. And this is called the capital allocation up here, the capital allocation line. The capital allocation line. And what that line is going to represent then, the CAL, I'm going to go ahead and put it over here so I have to rewrite this. The capital allocation line, what each point is going to, there's going to be points all along here. Okay? Each of these points on this line represent really two different things. A point on this line can represent, obviously, the risk associated with this portfolio. This portfolio is made up of what? Between the risk-free asset and the risky asset. So this point represents the risk return that you would earn from holding that portfolio. And that point also represents the percentage of your money invested in T-bills and the risky portfolio. Right here, this is what we're doing. So by definition, the capital allocation line is measuring two things. It measures the percentage of your money allocated between the risky portfolio and the risk-free portfolio, and it represents that corresponding risk-return trade-off point. Okay, you need both things to understand it's both things. So what is this line? This is a straight line. How can we calculate what this line is going to look like? Well, we're looking at this as the independent variable. This is the dependent. As we increase our risk, our return goes up. So what we can do is we can go through here and make a calculation here. So I'm going to set up another way we can calculate the return of a complete portfolio using this particular line. Well, let's take the two endpoints to develop our line. Let's take this extreme and this extreme. If I move from 100% risk-free asset to 100% in the risky portfolio, what happened to my rate of return? How much did my rate of return go up? Okay, this is a slope. Remember, is sort of the rise over the. Remember, it's the rise over the run. Well, here it was 3%. If I put all of my money into over here, it rises to what? 12%. The differential between these things is 12 minus 3 is the 9%. So what we have here is RP minus RF. So the differential is going to be the RP minus RF. Okay. Now, how about the run? Okay. The slope of this line is going to be, this goes up this far. Okay. This goes up this far. So it's the division. This divided through by this change. Well, this change is what? The change is 0. It went from 0 to 18. Sigma C minus 0 is going to be 18, or sigma C minus 0 is sigma C, or not sigma C in this case, it's going to be sigma P, because sigma C is sigma P in this example, but this is the point we're looking at. Okay. Sigma P, so this is going to be under sigma P. Well, this is the slope. This is the slope of this capital allocation line right here. Okay. Now, how about the intercept? Remember, a line is an intercept plus the slope times the independent variable. Well, the intercept is right here. It's RF. So it's going to be RF, okay, RF plus the slope. And what is changing here? The thing is changing is my independent variable is sigma C. Remember, as we move along here, each of these points represents a different allocation between the risky asset and the risk-free asset. Each one of these will have a different sigma C. Okay? It just so happens here the sigma P is sigma C way out this end. So we need to multiply this times sigma C. So there's our equation right here. There's our generic equation. And so I can pick different levels of risk that I want to hold, okay? And I can use that information to calculate what is the corresponding rate of return in this case. So let's put our equation up here. This equation is going to be of what? We got RF is going to be, so this here is going to be equal to 3%. Just plugging in is the 3% plus, okay? We've got 12 minus 3 is 9. Let's just do this over here. So we've got the slope is going to be 12 minus 3. 12 minus 3 divided through by what? The standard deviation of sigma P divided through by 18. This here is equal to what? 0.50. 0.50. This slope right here is referred to as the reward to variability ratio. A reward to variability ratio. What is that? What is the reward? The reward is your rate of return. What's the variability? The variability is your risk, right? This is a reward to risk ratio. So what does the 0.50 mean here? It means every time I increase, if I increase my risk by 1 unit, and our units in this case are percentages, if I increase my risk by 1%, okay, my rate of return increases by what? 0.5%. That's the definition. If I increase my risk by 10%, okay, then my rate of return is going to increase by 10 times that, will go up by 5%. Okay, that's what it's measuring. That's the interpretation for this right here. Okay, so let's finish out. So we've got here, this is equal to 0.50 times sigma C. Okay, so this is my RC. This is what this is going to equal. Well, if everything is working out right, I darn well better get the same answer here as I got up here in using, I remember in this equation up here in calculating this, this was not even used. This was simply a weighted average between what? 12%, 60% here, and 3%, and 40% earning 3% right here. So if we plug into this equation, what is the sigma C in this scenario? It's going to be this right here. Okay, so it's got to, that should be matching out. So my RC in this case, using this equation, is going to be 3 plus 0.50 times 10.8. So let's go ahead and do the math here. So 10.8 plus this right here, of course, is 5.4. 5.4 plus 3 equals 8.4%. And that's exactly what we had up here. This was calculated based on the rate, on a blended rate of return between these two securities. This down here was calculated based on how much money you had invested between the risky asset and the risk-free asset. Okay, I will come back. I'll set up another video. Maybe we'll work through a few example problems for you from some things in the back of the chapter. Also, I should have up there for you the solutions to the back of the chapter questions if you want to take a look at those and to help you work through them. Anyways, if you have any questions, again, you can either email me questions up onto the discussion board. Of course, you can text me as well. If you really need to, you can give me a call. Thank you very much, and I'll see you again soon.